So hello everyone. So I've already introduced myself previously, but my name is Amir Erez. I'm heading what we call the telecom division or the networking division here in Israel. So I'm running the business part of Wind River here in Israel for the telecom or for the networking vertical. And what I would like to discuss with you today is, guys. So what I would like to discuss today is a bit about the foundation for NFV, or what makes a successful NFV type of a solution. So before going deep dive on that, just a quick view of what I'm going to present here. So a quick introduction of Wind River. So I'm guessing most of you know the company, but just say a few words about the business challenges, and as I mentioned, the foundation for NFV. So this is just, what we're going to discuss today. So starting with Wind River. So I mentioned that before, Wind River was established actually back in 1981 as an embedded tools and operating system company. So I'm guessing that some of you know VxWorks or work with that. So this was like the flagship of the company for many years. Company went public in 1993, but I think the most affecting event on the company was in 2009. As I mentioned before, the company was acquired by Intel, so we are actually a fully owned subsidiary of Intel. What actually does it mean? It means is that Intel, when it bought Wind River, she was already thinking about the next stage, what we are now calling the NFV, the OpenStack, the cloud environment for the telecom, and what is the way to support their penetration towards that market. So they are doing that with Wind River solutions. So we came from the operating system, from the telecom market. You might notice here, the top 20 telecom equipment suppliers that are actually our customers. So we are coming from this market, from the embedded and from the telecom market, and we are now doing the foundation for what is actually the cloud, the NFV solution for Intel, working hand by Intel. Just maybe one note on that slide before moving forward is the industry leader in R&D investment. It's actually not 70, it's $19 million of R&D investment per year. I think it's one of the, making us like a leader in this market in terms of investment. I mentioned that part of this investment is actually put here in Israel. We have 20 plus R&D guys working in our Ra'anana facility. Most of the development is actually done in California. So NFV, OpenStack related products done here. So this is like in a nutshell about Wind River. So a bit about business challenges. You saw that slide before, so I just maybe go really quick on that. So increasing traffic, we all know about that, and we all know that, people are, service providers are calling our home saying if you have 30, maybe go to 100 or 200 megs to your home. So the pipes are getting bigger, and the service provider need to somehow address this need. The way to do it, probably adjusting multi-core platform. You all now in the industry are doing that, and trying to minimize the time it takes us to get the products out. How do we do that? This is exactly what we will speak about in the next few slides. Getting cooperation, not doing everything yourself, but doing the added value yourself and getting the basic or the fundamental blocks from third-party companies. So this is one challenge. Second one is, of course, the TCO. Companies want to get better revenues, want to better their profit, their bottom line. How do you do that? You go virtualize, you go to NFV. We see this as a trend, we see that this is happening. This is why, people mentioned here before me that the OpenStack event is getting bigger and bigger every year. This is actually a trend coming from going to the cloud, going virtualize. We are also there. The third one is how to actually improve on the ARPU, the ARPU. How do we increase the revenue we get from each customer? And this is by introducing more intelligent services. Doing that by using, actually we need to do DPI. We need to look into the traffic, and while looking into the traffic, we can have more intelligent services. intelligent caching, intelligent security, billing, and so forth. So those are the three challenges, and this is how the market is looking today and will keep on growing in the years to come. So next one is going actually to the NFV and doing more deep dive. So what are the challenges in the NFV market? So first of all, when we are looking at that challenge, we are looking at getting a product into the telecom or the service provider infrastructure. So first thing we have to keep in mind is how we integrate our product into their system, right? This is, they already have a fully deployed services going in one certain way. They have their own OSS and BSS infrastructure. So first of all, we have to find a way, or we have to think of how do we interface with those OSS or BSS infrastructure. The provisioning, the management, all those kind of automated mechanism that is already there. Second of all, we are going virtualized. That is nice. This is something that we know what is the motivation for that, but what is the penalty on the other side? So penalty is usually comes in terms of degradation in performance, so we have to deal with that. So we are offering new services. We are going to markets that consume more traffic, but actually we are going to platform which enable us or does not enable us better performance, because in the sense of it or in the nature of it, it is running on top of another layer on x86 servers, which are not dedicated hardware. So this is a second very dramatic challenge, and I will address it later on. The third one, which is also something I will put a focus on in the next couple of slides, is the SLA. So a word of caution. So when we are building an NFV, it's not just building, taking an operating system, some sort of a Linux distribution, putting a KVM or Xen or any type of virtualization on top of that, and here we go, we have a virtual solution. Well, it's the opposite of it. And that's because we are now looking at the telecom market. Telecom market is asking us for a different level of management, high availability of our product, a different type of security, and of course a whole different level of performance. So what is 30 seconds versus 300 minutes? What is the ratio here? Someone quickly? 600, yeah, I saw someone there saying 600. So what are those two numbers? So 30 seconds is what a telecom system will allow you to have 30 seconds of downtime in a year, okay? This is actually 6.9. So when I'm building a system which is supposed to address the telecom market, this is the number I need to support. 30 seconds of maximum, 30 seconds of downtime a year. If we are looking at enterprise level, type of solution, this is what I'm allowing, and a maximum of 300 minutes per year. So a major difference here, so when looking at building such a solution. So 6.9, this is a carrier grade device, 30 seconds of downtime per year. This is what we have to think about. So this is not something we can achieve along the way. This is something that once we are building our architecture, we have to build it from the bottom to be able to support that kind of thing. We cannot take an enterprise kind of infrastructure and adjust it. This is something you build from the ground up. So we discussed a bit about the challenges, and then afterwards, what are the challenges specifically for NFV? Now look at what is actually the architecture for such an NFV OpenStack machine. So the baseline is, of course, a commodity server platform, any type of x86 servers. On top of that, we have to have a layer of operating system. So in our case, it's, of course, a Linux operating system, Wind River Linux distribution, with what we call a carrier-grade profile. Again, sort of packages that enable us to be 6.9s. So Linux OS with carrier-grade profile. Next thing you have to put on top is some sort of a virtualization, right? This is what NFV is all about. So open source KVM, it could be any other, but what we have done is taking the KVM and commercializing it and making it carrier grade. What it actually means is taking the KVM and enabling it with low latency. If we're speaking about interrupts, so if a KVM, an open source KVM, can reach around, I don't know, something in the interrupts around 800 microseconds, in our KVM, or in our what we call open virtualization profile, which is an enhanced KVM, we are getting to numbers somewhere around 3 microseconds in terms of interrupts. So this is, again, I'm always repeating that, carrier grade. This is what we always have to think about. And of course, real-time extension. So getting this product commercialized in terms of QA, in terms of stability, and getting those attributes of low latency and real-time extension. So now we have a platform, we have a carrier-grade Linux, and on top a carrier-grade virtualization solution. On top of that, now we need to do some switching, some traffic forwarding between the different machines. Here we are using the accelerated vSwitch. This is actually utilizing Intel DPDK. So I've mentioned before, we are an Intel company. We are working very closely with their R&D. And we came out with this acceleration vSwitch that enabled us a very, very rapid switching between the different virtualized machines. Another part here is, of course, the OpenStack. So we need to be part of this orchestration, part of the cloud. So we have our commercial OpenStack distribution. This is what we see here. But again, the OpenStack on its own is not enough for taking a machine and having it as an NFV-ready machine. So what we have managed, what we have put additional here is, of course, high availability for the management, virtual machine health monitoring. What does it mean? It means that when I have different applications running on top of my NFV, I am doing heartbeat. I'm checking whether this application is still alive, and if it's not, I can migrate it really quickly to another machine. Power management. If I don't have all those servers running and doing anything, I can turn some of them off and turn them on when the demand is there. And of course, additional carrier-grade middleware like operating, administration, and maintenance provisioning, software management, security, and high availability for storage. So all of those added packages are part of what we call NFV. So when we are facing a challenge of building an NFV machine, we have to look at each one of those steps. Let's go to another layer, which is almost the last one, which is actually the virtual machines. So, of course, every virtual machine can run any type of service on top of it. And of course, it can also support any type of operating system on top of that, okay? So we are trying to be as standard as possible, so we will enable our customers, our telecom provider to be as quick and as efficient with service enabling. Another thing that we provide is actually what we call the INP, is the accelerating part. So the ability to use the machine, the x86, as efficient as possible, use all CPUs in terms of load balancing, reuse of code written for the kernel, and actually having those VM act as fast as possible. This is the INP. Another part of the INP is the DPI that I mentioned earlier, flow analysis and pattern matching. And the last part is, of course, as I mentioned, the NFV orchestration and the interface for the OSS BSS. So this is an NFV machine that is already ready and working in Wind River and can do as a plug and play in any kind of tier one kind of a cloud. So just as a summary of that, so we are using the TL900 methodology in order to reach 6 nines, rates of 10 and more gigabyte, issues that we address like geographical redundancy over standard IP, 10 microsecond of interrupts, and fully integrated telecom grade security, AA access, and so forth. So this is what we have as an NFV ready machine. But many of you saying, listen, we are going towards NFV, we are having our sense of how this machine should look like, but on the other hand, so we don't want the complete solution, But what we do not want to do everything on our own. We do want to do, we spoke about how to get all sorts of partnership in order to get better time to market, right? So we can do everything on our own, but we want to be faster and we want to spend less money. So we do offer this NFV solution in parts, in modules. So you can have the Linux carrier grade operating system as one part. You can have the open virtualization, those advanced KVM that I mentioned, as a package. You can have the INP, taking the packet acceleration, the content inspection on the flow analysis, each one of them as a package just to allow you to do, I don't know, intelligent kind of traffic steering using flow analysis or doing some sort of engine which is pattern matching with the content inspection. Commercial OpenStack, I discussed it, or carrier-grade communication server, which is actually, this is the complete machine. So you can get to this carrier-grade communication server that I demonstrated earlier by using all of those, or each one of those components and building your own kind of solution. Again, mentioning that you are doing better time to market and decreasing the amount of money you spend towards this solution. So this is our offering in terms of getting this in, in a step-by-step. So I'm doing it a bit shorter, so this is the summary. We discussed about the telecom providers' challenges, right? So we said that they are going towards NFV, they are going towards OpenStack, they want to decrease their, the capital expenditures and operating expenditures, but they have to do it in a way that they will keep their SLA as they do today. So 9 nines, issues of performance, security, this is the most major things that we have to look at. So this is actually what we are about. We are about enabling you this infrastructure, enable you a carrier-grade kind of an infrastructure all along the way or as a complete solution. So that's it. I'm be happy to get any question from the crowd. So please feel free. Yeah.
Some acceleration on top of standard Linux.
Yeah, the acceleration solution which I mentioned, the INP. Okay, so first of all, maybe a few words. It is, as I mentioned, it's built on top of the DPDK, and it is allow us to get us to really a high performance using better utilization, load balancing of the traffic between the different cores and a new stack in the user space. And this is not related to the lower level, I would call it, that I saw before. So you can get it on any Linux, not just Wind River Linux. It's a standalone. By the way, that's the same goes for our Hyperscan or for our flow analysis engine, which is partnership that we are doing with Cosmos, if you know, that we are the world leader in that aspect. So all of those are not dependent on the lower layer of the Wind River Linux. You can run it on any type of Linux. Yeah.
5 or 6 nines that you mentioned, isn't that required just at the service level and not each for each computer?
Yeah, actually it's required in the service level, but in order to support this service layer of 6.9, you have to have the underlying, This is exactly what I'm talking about. So you want to have redundancy. So let's say you have a certain server, a certain service running on a certain server, hardware server, and this service is being interrupted for some reason, and you want to actually understand that it went down and get it to another server without interrupting the service. This is what 6.9 is all about. So how do you get this understanding that the service is down? How do you get it up again on the other side in minimum downtime or not downtime whatsoever in certain microseconds? So this is part of the solution that I have just described. So the server itself are not, of course, 6.9, but the overlaying technology on top of that has to be 6.9. It has to be to support this type of mechanism, and this is what I've mentioned in the slides. Any other questions?
Which of those technologies actually also using the open source or
So maybe I'll go back to the slide. So just to show, which of those. One second. So the Linux is actually you get as an open source. This is the Linux. Same goes to open virtualization. So those are things that you get. You get the code. You get the code and you get to even enhance it if you like. By the way, we also get or get to keep the support level. So you may change, in our Linux, you may do some changes that may require in the kernel, or you may want to do some changes in the part of the KVM, but you still get our support from WinRiver. The INP, on the other hand, are binary. This is not open source, this is something we provide. Commercial OpenStack, of course, open, goes without saying. Okay, thank you very much. Toda rabba.